Linear Algebra, Lecture 4. I am given 4 points, A, B, C, D. Point A and point B are in the 2-dimension XY space. Point C and point D are in given XYZ 3-dimensional space. Okay. So what we want to find, we want to find AB and CD. AB and CD are 2 vectors. AB means you draw a line from point A to point B. CD means you draw a line from point C to point D. Therefore, AB is a vector and CD is also a vector. And I want to find these 2 vectors. AB is from A to B. The vector AB are the coordinates of point B subtract the coordinates of point A. The x-coordinate subtract the x-coordinate. The y-coordinate subtract y-coordinate. So the B is 3, 4. Minus 1, 2. And this x minus x, y minus y. Therefore, this is equal to 2 and 2. So this becomes a vector now, 2, 2. CD. I just do it very quickly. CD, you subtract the coordinates of D, subtract the coordinates of D to subtract coordinates of C. So CD is 1 minus 0 is 1. 0 minus negative 2 is 2. 2 minus 3 is negative 1. So this is 1, 2, negative 1. All right, this is this example. Let's go to the next example. The next example. All right, I want to solve these 3 equations. I have 3 unknowns, x, y, z. I have 3 equations. 3 equations with 3 unknowns. I want to solve it. Solve means find x equals what, y equals what, and z equals what. 3 equations, 3 unknowns. I have a system of equations. We have learned how to solve a system of equations before. And we remember there are usually 2 methods. One is called substitution, and the other is called elimination. This method is just algebra. Let's do this first, algebra first. The first equation has no y. Therefore, this gives us an idea that the first equation already has only x and z, no y. So why not let us eliminate y from the second and third equation. This way, we will have only x and z. How do we eliminate y from the second and the third equations? Subtract y. You understand? Just subtract. So this is 2. The last one is equation 3. So I do this. Equation 2 minus equation 3, x minus negative 2x, 3x, y minus y is gone. Z minus negative z is 2z. Negative 1 minus 2, negative 3. Let me double check sometimes you just copy something wrong. So I double check everything is correct. Now I have x plus z is negative 1. So I rewrite the first equation. Now I have x plus z equals negative 1. Multiply this equation by 2. Okay, let me label this 2 times 5. I call 6. Now I have 2z here, 2z there. So I can subtract these two equations, 4 minus 6. Three x minus 2x. 2z minus 2z. It's gone. Minus 3, subtract minus 2 is minus 1. Therefore, I have x equals minus 1. Once I have x, I can find the other unknowns. Put x into 1, put 7 into 1. X is negative 1. So negative 1 plus what is equal to negative 1? Negative 1 plus what is equal to negative 1? So negative 1 plus 0 is equal to negative 1. Therefore, z is 0. Now look at the second equation. X is negative 1. So this is negative 1. But look, the right-hand side is also negative 1. So this negative 1 plus something is negative 1. So these two terms should be 0, right? But I already have z is 0. So x plus y, negative 1 plus y equals negative 1. So y has to be 0 as well. So I have y equals 0. Therefore, my answer is negative 1, 0, 0. This is to use algebra to solve the system of equations. But we are talking about linear algebra. Therefore, let's use matrix method. So let's do this again using matrix. Subtract the erases. Rewrite the given three equations using matrix. let's see, 1, no y, 1, negative 1. 1, 1, 1. Negative 1. Negative 2. 1, negative 1. 2. I have this matrix. Let's do this. Eliminate this. So I can use this row to subtract this row. Then 1 minus 1 becomes 0. So I have, I should erase this to have more space. Let me leave the answers there. So I have 1, 0, 1, negative 1. 1 minus 1 is 0. 0 minus 1 is minus 1. 1 minus 1 is again 0. Negative 1 minus negative 1 is again 0. I want to make this 0 also. So what I do is multiply 2 and add this. 2 times 1 is 2. 2 plus negative 2 is 0. So, two times 0 is 0, plus 1 is 1. 2 times 1 is 2. 2 plus negative 1 is 1. 2 times negative 1 is negative 2. Negative 2 plus 2 is 0. So I have this matrix. This is just repeat row 1. Let me erase this part to have more space. This is just row 1. This is row 1 plus row 2. This one is 2 times, oh no, it's not plus, I'm sorry. Row 1 minus row 2. And this row, I get 2 times row 1 plus row 3. So I have this. Next, I want this to be 0. How do I do that? It's just this plus that, this plus that, this becomes 0. So I need more space. So I have 1, 0, 1, negative 1. 0, negative 1, 0, 0. This plus that. Okay. 0 plus 0 is 0. Negative 1 plus 1 is 0. 0 plus 1 is 1. 0 plus 0 is 0. So I call this row 1, row 2, row 3. So this is how I get this. This is 1, 2, 3. So I can call this 4, 5, 6. So how do I get this? This is just 4. This is just 4. And this one is just 5. And this is just 5 plus 6. Next, I want this to be 0. How do I get this 0? I use this, subtract this, because I see 1 minus 1, this becomes 0. So, this is 7, 8, 9. So, row 7 minus row 9. So row 7 minus 9, 1 minus 0 is 1, 0 minus 0 is 0, 1 minus 1 is 0, negative 1 minus 0 is 0. Oh, negative 1 minus 0 is not 0. Sorry, it's negative 1. Just repeat. 8, 0 minus 1, 0, 0. Repeat. 9, 0, 0, 1, 0. So I have this matrix now. Let me have more space. I erase something. I erase this. I don't like this negative 1. So I multiply this row by negative 1, and then it becomes positive 1. Okay. So now I becomes 1, 0, 0, negative 1. Multiply the second row by negative 1. Keep the last row. So now this is called reduced row echelon. I have 1, 1, 1, and everything else is 0. So what are my x, y, z? X is negative 1 here. Y is 0. Z is 0. So, yeah, this is the same as that. So I can use matrix to find my answer. I can also use algebra to find my answer. All right, that's the second example. The third one, next one. I am given a matrix, but the matrix actually represents equations. So I have 4 equations, 3 unknowns. This is x, this column is x, y, z, and this is on the right-hand side of the equal sign. I have 3 equations, 3 unknowns, and I want to solve for x, y, z. So the matrix represents equations. So I have x plus 7y plus 3z equals -4. I have y minus z equals 3. I have 0 equals 1. I have z equals -2. Look at the third equation. I have 0, no x, no y, no z, equals 1. This is not true. 0 is not equal to 1. So what's the solution? No answer, no solution. That answers this example. Next example. I am given P and Q. I want to find P plus Q, P minus Q, absolute value of P, absolute value of Q, or you say magnitude of P, magnitude of Q. I want 2P, 3Q. First of all, the P looks like a point because I have x, y, z. A point in three-dimensional space. I want P plus Q. What do I mean by a point plus a point? It doesn't tell me too much. How can I add a point to a point? So this question, you must interpret. This is not a point, this is a vector. The vector has 2 points, the beginning and the end. This P is the point, the end point of the vector. What is the beginning point of the vector? It's the origin. So actually this P is OP. This Q is OQ. You have 2 vectors, you want to add 2 vectors. So this is the understanding of the problem. Actually, this question is taken from a textbook. But in a textbook, there is no such confusion. How can you tell it's a point or a vector? Because in a textbook, you can have boldface to represent vector. Not boldface represent a point. The printing is different. But when I write it, I cannot write boldface. It's too, it's not convenient. I mean, if not possible, it's not convenient. So a boldface represents a vector. So I can, to show this a vector, maybe I should put a arrow before above it. The vector P is from the origin to this point. So once I know it's a vector, then I know how to add vectors. To add vectors, you just add the x component to the other x component, y component plus y component, z component plus z component. Therefore, the first answer, P plus Q, two plus root 2. 2 plus square root 2. This plus that is 3. This plus that is 0. So, I have P plus Q now. Do I have this? Yeah. P plus Q. All right. And then P minus Q. This minus that. This minus that. This minus that. All right. What's the P magnitude? Remember, if you have a vector, oh, by the way, this is a vector, the magnitude of vector. In writing, the vector label, you should put an arrow. You put an arrow above the letter, so it means a vector. But usually in writing, particularly a teacher writes something on the whiteboard or blackboard, let's make it simpler enough. A vector, just do this. That's a vector, all right? Instead of doing that. Well, that doesn't matter. How do you use a label? It doesn't matter. Okay, as long as we understand what we are doing. So how do you find the magnitude of the vector? It's a square of all the components and sum. The sum of the three components, the square of the three components, you add them up, and then take square root. So that's magnitude or absolute value. So you understand that. You understand that well, right? You learn that it's in 2 dimensions. This is a vector, and this is the x component, and this is a y component. So the magnitude is, that's a magnitude or absolute value. But I have 3 dimensions, so you just add in 3 dimensions. So the magnitude is this. Therefore, P is square root 2 square plus -3 square plus 5 square. 4 plus 9 plus 25, and this is 3. Okay, the magnitude of P vector is square root 38. The Q vector Q vector magnitude is just do the same thing. And you just do it. It is okay. How about 2p? 2p is, and we understand p is a vector, so 2p is, you make the p vector longer, 2 times longer. So you multiply every component by 2, you have 4, -6, 10. How about 3q? No, 3q. 3q. Q is a vector. Then you have 3 times this. Okay. So this is very easy. Huh? You understand quite well. You studied vectors in the course, in the Ontario course, calculus and vectors, right? You studied vectors, and these are just vectors. Okay, but when you study linear algebra, the introductory part is to talk about vectors, talk about matrices. So this is just an introduction. Although it is lecture 4, it's still an introduction. It is not difficult at all. So that's all for today's lecture. Thank you for watching. We will continue next time. Goodbye.